Hey everyone, it's Matt with Techstreet. I'm inviting you to watch this video on the 2023 ASME key changes to the BPVC documents. We hope that you enjoyed this webinar.
Thank you everyone for joining us here at Techstreet along with ASME for our ASME boiler and pressure vessel code presentation outlining the key changes for 2023. I'm joined today with our speakers and moderators, Chris Mahler from ASME. He's the Director of Engagement and Outreach for Conformity Assessment, and Stephen Rossi from ASME, Project Engineering Manager with the Standards and Engineering Services.
Thank you very much, Matt. Before we begin, I just want to give you a setup of how we're going to do this presentation today. Today, Steve and I are going to be doing the presentation in two parts. The first part is a brief review of the boiler vessel code sections, and the second part, Steve is going to go over each section's key changes to the upcoming boiler code, which will be released in July. Just very briefly about ASME, for those that aren't familiar. The American Society of Mechanical Engineers is a not-for-profit international association whose main goal really is to help engineering communities develop solutions to real-world challenges. ASME was established in 1880. Our headquarters are in New York City. We do have a global reach with offices in India and China, as well as an active presence in Europe. We have 90,000 members worldwide, spread around 135 different countries. We hold approximately 25 conferences per year. We do publish journals, conference proceedings, as well as technical books. Also, we have over 200 courses that address technical topics that are engineering related. ASME standards are placed into four categories: standardization and testing, safety, nuclear, and pressure tech. We have over 500 standards covering a wide breadth of topics. These include pressure vessels, piping, nuclear technology, elevators, escalators, cranes, hoists, derricks, as well as performance testing, among others. ASME standards are used in over 100 different countries. Standards and the development process is maintained by over 5,500 volunteers who contribute their technical expertise to develop our standards. And these standards enhance public safety, health, and the quality of life. Our standards are accredited by ANSI, and they adhere to the principles and procedures that are outlined by the World Trade Organization's Agreement on Technical Barriers to Trade for the Development of International Standards. They include transparency, openness, impartiality, effectiveness, coherence, as well as development dimensions. Issued every 2 years, the Boiler Pressure Vessel Code sets the standards for the safe design, manufacture, and maintenance of boiler and pressure vessels, power-producing machines, and nuclear power plant components. They also provide the latest information to maintain the ASME code symbol stamps. The next scheduled release of the Boiler Code is going to be July 2023. This edition is going to have 32 books with over 19,500 pages of material. The Boiler Code is a living document. It is constantly evolving. It is constantly providing essential rules and requirements for new materials, applications, and technologies, including material properties, as well as specifications for construction, safety rules and guidelines, proper care and maintenance requirements for pressure devices, as well as design and construction criteria across devices and components. Non-nuclear sections of the Boiler Code include construction of power and heating boilers, recommended guidelines and care for both construction of pressure vessels, as well as working with reinforced plastic pressure vessels and transport tanks. The first part that we're going to cover is going to be the boiler sections. For all types of power, electric, and miniature boilers, as well as high temperature water boilers, heat recovery steam generators, and specific fired pressure vessels to be used in stationary services, Section 1 specifies the construction requirements. It also covers power boilers used in locomotives, portable, and traction services. There are also guidelines for using the ASME certification marks. Those marks are going to be S, A, M, E, PP, and the PRT designator. Section 4 outlines the specifications for steam heating, hot water supply boilers, and potable water heaters intended for low pressure services that are directly fueled by gas, oil, electric, coal, or other solid or liquid fuels. These heaters must also meet standards for design, fabrication, installation, and inspection. It also includes appendices that define terms related to the boiler design, welding, quality control system, methods of determining safety valve and safety relief valve capacities. Included in Section 4 are also going to be your guidelines for using H, HLW, and PRT product certification marks. Section 6 covers the general descriptions, terminologies, and operation guidelines applicable to steel and cast iron boilers, limited to the operating ranges of Section 4 heating boilers. It includes guidelines for associated controls and automatic fuel burning equipment. Also included is a glossary of terms commonly associated with boilers, controls, and fuel burning equipment. Section 7 provides guidance and best practices for the use of power boilers in a safe manner. While locomotive and high temperature water boilers, nuclear power plant boilers, heating boilers, pressure vessels, and marine boilers are all excluded from the definition of a power boiler, it does cover stationary, portable, and traction type boilers. The instructions provided in Section 7 help individuals who are directly in charge of running, maintaining, and inspecting power boilers. The next non-nuclear section of the code is pressure vessels. Division 1 of Section 8 provides requirements applicable to the design, fabrication, inspection, testing, and certification of pressure vessels operating at either internal or external pressures exceeding 15 psi. Specific requirements apply to several classes of material used in pressure vessel construction and to fabrication methods such as welding, forging, and brazing. It also contains mandatory and non-mandatory appendices detailing supplementary design criteria, non-destructive examination, and inspection acceptance criteria. Rules pertaining to the use of U, UM, and PRT certification marks are also included. Division 2 of Section 8 provides an alternative to minimum requirements for pressure vessels under Division 1 rules. In comparison to Division 1, Division 2 requirements on material, design, and non-destructive examination are more rigorous. Division 2 rules cover only vessels to be installed in a fixed location for a specific service, while operation and maintenance control is retained during the life of the vessel by the user who prepares the design and specification. These rules may also apply to human occupancy pressure vessels typically found in the diving industry. Rules pertaining to the use of the U2 certification mark are included. There are specific differences between Division 1 and Division 2. Division 1 is concentrated on a design by rule approach, and Division 2 is design by analysis approach. Division 1's design by rule approach is most utilized by engineers to size the pressure vessel according to the appliance's requirements. Division 1 is a much more conservative rule approach. The empirical relations and other mandatory and non-mandatory criteria often end up in an upscale pressure vessel design. Division 2, design by analysis approach, requires more detailed calculation than Division 1. Although this may increase the value of the pressure vessel design, it allows pressure vessels to face up to higher stresses. It's also meant for purpose-specific vessels with an outlined fixed location. Another major difference between 1 and 2 lies in the failure theory. Division 1 is predicated on normal stress theory, and Division 2 is predicated on maximum distortion energy. Division 3 of Section 8 provides rules for pressure vessels that operate at pressures exceeding 10,000 psi. Division 3 does not establish maximum pressure limits for either Section 8, Division 1 or 2, nor does it establish a minimum pressure limit for itself. Division 3 provides the rules that dictate the use of the ASME certification mark, the U3 designator. Section 10 provides requirements for construction of an FRP pressure vessel in conformance with the manufacturer's design report. Section 10 covers requirements needed to produce, process, fabricate, examine, and test methods for the vessel. 3 classes of vessel designs are covered in this section. Classes 1 and Class 3, they're qualified by destructive testing of a prototype, and Class 2, which is subject to required design guidelines and acceptance testing using non-destructive techniques. These vessels are not designed for lethal fluids. The only allowable techniques that can be used to fabricate vessels under Section 10 are bag molding, centrifugal casting, filament winding, and contact molding. There are also guidelines for using the RP certification mark. The rules of Section 12 constitutes requirements for construction and continued service of pressure vessels for transportation of dangerous goods. This can be via highway, rail, air, or water. Construction, material, design, fabrication, examination, inspection, testing, certification, and overpressure protection are also addressed. Continued service is addressed, referring to inspection, testing, repair, alteration, and recertification of a transport tank that's already previously been in service. Included are also rules pertaining to the T and PRT certification product mark. The next sections we're covering are the nuclear sections, Section 3 and Section 11. Section 3 covers construction of nuclear facility components. The scope is intended to cover construction of components for all types of nuclear power plants. Division 1 covers your metallic vessels, heat exchangers, storage tanks, piping systems, pumps, valves, core support structures, supports, and similar items. It also provides rules for the low temperature light water reactors. Division 2 contains requirements for material, design, construction, fabrication, testing, examination, and overpressure protection of concrete containment structures. These structures can be pre-stressed or reinforced. Division 3 contains requirements for the design and construction of containment systems for nuclear spent fuel. Division 4 is fusion energy devices. This is currently a placeholder for future content. The upcoming Boiler Code 2023 will incorporate the components of FE1-2018 Rules for Construction of Fusion Energy Devices. And finally, Division 5, High Temperature Reactors provide suitable rules for construction of gas and liquid cooled reactors. Section 11 constitutes requirements to maintain the power plant while in operation and return the plant to service following plant outages, repair, or replacement activities. Division 1 is inspection and testing of components of light water cooled plants. And Division 2 is reliability integrity management. The first edition was published in 2019 and it includes a methodology to establish in-service inspection criteria independent of an SMR's technology. Division 2 is technology neutral and is applicable to all reactor designs. The final section of the code are our service sections, and we'll cover them starting with Section 2. Starting with Section 2 of the service section, materials. Materials are broken into 4 parts. Part A is ferrous material. Part B is non-ferrous material specifications. Part C is specification for welding rods, electrodes, and filler metals. And we have Part D properties, which are customary or metric. It provides tables for the design stress values, tensile and yield stress values, as well as tables for material properties. Moving on to Section 5 of the service section. Section 5 contains requirements and methods for non-destructive examination, which are referenced and required in other code sections. It also includes manufacturer's examination responsibility, duties of authorized inspectors, and requirements for qualification of personnel, inspection, and examination. Section 9 contains the rules related to qualification of welding, brazing, and fusion procedures as required by other code sections for component manufacturers. It also covers rules related to the qualification and requalifications of welders, brazers, and welding, brazing, and fusion machine operators as required by other code sections. And finally, Section 13. Section 13 was originally released in 2021. This is a newer section. It provides rules for overpressure protection, pressurized equipment such as boilers, pressure vessels, and piping systems. One of the main benefits of Section 13 is that it is organizing all requirements by pressure relief device types, including any exceptions or unique ones that are identified in a specific boiler code section, which enables users to easily identify all requirements across a device. In addition, Section 13 places capacity certification requirements across the code's many sections into one centralized location. Errata to the boiler code may be posted on the ASME website to provide corrections to incorrectly published items or to correct typographical or grammatical errors in the boiler code. Erratas are announced through postings on the ASME website immediately after receiving approval from the respective code section committees. To gain access to the postings of these erratas through the boiler pressure vessel resource page, that can be found at www.asme.org. In addition, you can also subscribe to notifications for erratas for each and every ASME boiler pressure vessel code section. In the event of an urgent need for alternate rules concerning materials, constructions, or in-service inspection activities not covered by existing boiler pressure vessel code rules, or the need for early implementation of an approved code revision, ASME may issue a code case. Code cases are effective immediately upon ASME approval. Code cases do not expire. Code cases are published in two categories. They're either published in boiler pressure vessel or nuclear. Purchases of either compilations of approved code cases include a subscription to the corresponding supplements contained in new and revised code cases issued during the associated 2-year edition cycle. We also issue interpretations. Interpretations clarify existing code requirements where there is ambiguous wording in the standard. ASME issues written replies to inquiries concerning interpretations of technical aspects of the code. The interpretations of each individual section will be published separately and will be included as part of the update service to that section. Interpretations of Section 3, Division 1 and 2 will be included with the updated service to Subsection NCA. Interpretations are published twice a year, January and July. ASME certification programs are globally recognized. Our certification programs help companies comply with regulations, achieve process efficiencies, reduce costs, and increase the product's reliability, quality, and safety. The map on the screen shows ASME's reach with certification. Presently, we have 6,900 certified manufacturers globally. That represents 11,500 certifications that are active. From a program standpoint, we have 4 stamping programs, 3 quality programs where we're certifying a program, not a product, 2 accreditation programs, and 2 personal certification programs for individuals. For an organization to be recognized as ASME certified, your company is going to go through a rigorous process to ensure every operation is compliant with the code and performed to the highest standard. Typically, the time for a company To be certified from the time they submit an application to the time they receive certification is approximately 6 months. The ASME certification mark covers nuclear and non-nuclear products and services which fall under the following categories. We have the boiler designators. We have 6 for power boilers under Section 1, 3 programs for heating boilers under Section 4. We have 5 certification programs for pressure vessels, 3 under Section 8, Division 1, 1 under Division 8, Section 8, Division 2, and 1 under Section 8, Division 3. One more time. Continuing with the non-nuclear boiler code certifications. We have 1 pressure vessel designator under Section 10, reinforced plastic vessels. For transport tanks, we have 2 designators under Section 12. And under our newest section, Section 13, there are 8 designators for certification. ASME's nuclear certification programs consist of 6 different N-type designators, as well as an owner certification. N-type certificates of authorization issued by ASME signifies that the certificate holder has been through a rigorous survey to verify the adequacy and the effective implementation of their quality program. If you do have an N stamp, it allows you to put that mark on the parts, components, and appliances used in nuclear facilities under Section 3 of the Boiler Code. One nuclear program that doesn't have a stamp is QSC, or the Nuclear Material Organization Certification Program. This program certifies organizations that are providing material to nuclear power plants in accordance with the requirements of Section 3, NCA 3800 and NCA 3900. It is a requirement for all ASME certificate holders to be on the latest edition of the Boiler Pressure Vessel Code within 6 months of its release. That's why if you are carrying a code stamp, if the code comes out on July 1st, you must be in compliance by January 1st. All code books are verified that they have been purchased through an authorized reseller, such as Techstreet, and the organization is required to designate who they purchased their code book during the application process when you are in CA Connect. This is just an example of the code books that would be necessary for an organization undergoing certification for a U or a UM certificate. And finally, we have a robust website. You can download all the information related to codes and standards and certification, as well as finding who your authorized resellers are and the books that you're needed for your certification program, or any related ancillary documents that are relevant to standards or your program. And with that, I would like to thank you very much, and I'll pass this over to Steve Rossi.
Thank you, Chris. Hello, everyone. My name is Steve Rossi. I'm a project engineering manager in Standards and Engineering Services, and also secretary for Section 8 and the Technical Oversight Management Committee. This presentation is a general summary of some of the major changes that will appear in the 2023 edition, the ASME Boiler and Pressure Vessel Code. All changes to the code will be available when the 2023 edition is issued on July 1st, 2023. The specific detailed changes should be carefully reviewed and verified as published in the 2023 edition to ensure compliance with code requirements when they become mandatory on January 1st, 2024. For Section 1, Rules for Construction of Power Boilers, tables PG 67.5 and PG 67.5M have been expanded and revised for the supercritical capacity correction factors in determining the rated relieving capacity of pressure relief devices. PW 28.1.3 has been revised to permit simultaneous qualification of well procedures by more than one organization. The Y factor table in PG 27.4.6 has been revised to make it consistent with Section 2D T notes. PW 39.2 was revised to address the use of buttering welds without post-weld heat treatment of both materials. Form P-4 was revised to include a section for documenting boiler external piping under qualifying conditions. And tables PG 67.5, PG 67.5M, PG 68.7, and PG 68.7M have been relocated to an appendix to improve readability of overpressure protection requirements. For Section 2, Part A, updates to the latest adopted edition have been made to over 60 specifications. 2 new specifications have been added, SA 439 and SA 1058. And 2 specifications were removed, SA 557 and SA 731. A new statement of policy on the use of ASME material specifications has been added. Mandatory Appendix 2 has been retitled to the Framework of ASME Material Specifications and has been completely rewritten. Updates to the latest adopted edition have been made to over 25 specifications under Section 2, Part B. The range of acceptable ASTM editions has been updated for a number of specifications. A new statement of policy on the use of ASME material specifications has been added. Mandatory Appendix 2 has been retitled to the Framework of ASME Material Specifications and has been completely rewritten. 14 AWS specifications for arc welding electrodes, gas welding rods, and other filament metals have been adopted or updated into the 2023 edition of Section 2, Part C. In Section 2, Part D, additions and revisions to stress tables and mechanical property tables have been made to support updated specifications. SA 283 Grade A and Grade B lines have been removed. The type grade column has been added to tables 2B and 5B, and many values have been populated. In code cases 2577, 2586-1, 2591, 2633, 2687-1, 2849, 2903, 2923 have been incorporated. Starting with subsection NCA of Section 3, NCA 3000 and 5000 have been updated to permit the use of newly published Section 11, Division 2, reliability and integrity management programs as a basis for designing for in-service monitoring and non-destructive examination. Table NCA 7100-2 has been updated to align with the revisions made to Table NCA 7100-1. Updates to the table include the identification of other acceptable additions and applicable subsections for listed reference standards. In the Section 3 Appendices book, mandatory appendices 11, 12, and L have been revised to extend the applicability to Section 3, Division 5, subsection HC, subpart B. Mandatory Appendix 13-1223 has been revised and updated to address the International Engineering Alliance and the European Federation of National Engineering Associations concerning the certifying engineer. Mandatory Appendix 28 was developed to allow for the usage of powdered metal hot isostatic pressing advanced manufacturing for the production of items made from 316L SS as one process method. Non-mandatory Appendix G-2223 has been revised to clarify toughness requirements for nozzles and to provide methods they may be used for external loads, thermal loads, and internal pressure as currently addressed. And Mandatory Appendix 26 has been revised and updated to include sidewall fusion, fittings, volumetric examination, and code case N-891. In subsection NB, Class 1 components, NB-2121A has been revised to permit the use of advanced manufacturing. This revision is to permit the use of advanced manufacturing product forms not included in Section 2, Part D, Subpart 1, Tables 2A, 2B, or Article NB-2000, provided that the product form meets the requirements of Mandatory Appendix 28. NB-2321.2 has been revised to remove the requirements to use full-size test specimens, and test specimen requirements were adjusted to be in accordance with SA 370. NB 5000 has been updated to permit the use of the newly published Section 11, Division 2 Reliability and Integrity Management Programs as a basis for designing for in-service monitoring and non-destructive examination. And NB 5540 has been developed to permit the use of CP 189 as an acceptable NDE personnel qualification standard. In subsection NCD, Class 2 and Class 3 components, NCD 2121A has been revised to permit the use of advanced manufacturing. This revision is to permit the use of advanced manufacturing product forms not included in Section 2, Part D, Subpart 1, Tables 2A or 2B, or Article NCD 2000, provided the product form meets the requirements of Mandatory Appendix 28. NCD 2321.2 has been revised to remove the requirement to use full-size test specimens, and test specimen requirements were adjusted to be in accordance with SA 370. NCD 3124 has been updated to permit the use of Section 11, Division 2 Reliability Integrity Management Programs as a basis for designing for in-service monitoring and non-destructive examination. And NCD 5540 has been developed to permit the use of CP 189 as an acceptable NDE personnel qualification standard. In subsection NE, Class MC components, NE 2321.2 has been revised to remove the requirement to use full-size test specimens, and test specimen requirements were adjusted to be in accordance with SA 370. NE 3125 has been updated to permit the use of Section 11, Division 2 as a basis for designing for in-service monitoring and non-destructive examination. NE 5540 has been developed to permit the use of CP 189 as an acceptable NDE personnel qualification standard. In subsection NF, supports NF 1000, NF 2000, NF 3000, Table NFD, and Appendix NFE have been revised for the addition of requirements for energy absorbers. Energy absorbing devices have not been fully defined prior to the noted revision. NF 2321.2 has been revised to remove requirements to use full-size test specimens, and test specimen requirements were adjusted to be in accordance with SA 370. NF 3300 has been revised to reflect applicable requirements for austenitic stainless steel design, found in AISC Design Guide 27. And NF 5540 has been developed to permit the use of CP 189 as an acceptable non-destructive examination personnel qualification standard. In subsection NG for support structures, NG 2321.2 has been revised to remove the requirement to use full-size test specimens, and test specimen requirements were adjusted to be in accordance with SA 370. NG 3200 and 3220 have been revised to facilitate merging primary stress limits, special stress limits, level C and level D limits, limit analysis, and experimental analysis into Section 3, Appendix 13-3000. An NG 5540 has been developed to permit the use of CP189 as an acceptable non-destructive examination personnel qualification standard. In Section 3, Division 2, CC-2331.2, CC 3532.1.7, and Table CC 4333-1 and Table D2-8-1410-1's requirements related to ASTM A615-20 have been updated to align with the current material requirements and grade options listed in the most current ASTM standard. CC-2466.2 now includes a note to clarify what constitutes a change in heat treatment conditions when pre-stressing elements materials. And CC 2522.1.2 has been revised to remove requirements to use full-size test specimens, and test specimen requirements were adjusted to be in accordance with SA 370. Section 3, Division 3, WB-2321.2, WC-2321.2, WD-2321.2 have been revised to remove requirements to use full-size test specimens, and test specimen requirements were adjusted to be in accordance with SA 370. This is the first edition of Section 3, Division 4. It is expected that the global fusion community will continue to develop these requirements based on lessons learned from the evolution of fusion power technologies and experiences. In Section 3, Division 5, Table HBB 3225-4 was revised to extend the thermal aging factor for Class A grade 91 components from 300,000 to 500,000 hours. Mandatory Appendix HBB I-14 tables were revised to extend stress rupture factor values for grade 91 from 300,000 to 500,000 hours. HBB T-1800 was revised to extend isochronous stress strain curves for grade 91 components from 300,000 to 500,000. HHA 3142 and HHB 3142 have been revised to remove damage dose unit and only use displacements per atom damage dose unit. Non-mandatory appendix HBBZ was added to provide guidance on constructing a suitable inelastic model from data and to offer designers an acceptable reference model for grade 91. And non-mandatory appendices HHBD and HHBE have been developed to cover carbon-carbon ceramic matrix composites. For Section 4, HG 715, HG 803, HLW 810, HLW 902, HLW 903, HLW 904, and HLW 906 were revised to support the proposed drain valve language in HG 803.2C3 and HG 803.3C2 in order to align with the requirements in code cases 2873 and 2983 so that it can be incorporated into the Section 4 code. Table 2-100 now references the latest edition, the CA-1 standard for conformity assessment requirements. And a provision was added to HLW 602 and HG 531 for the removal of a nameplate or marking of a part, but incorporating the part into a boiler that is to be certified. In Section 5, Article 1, T-120E has been modified to include exceptions made to SNTC-1A and CP-189. This eliminated the need for mandatory appendices 3 and 4, which were removed. A new and mandatory appendix for Article 12 was added on the evaluation of the sensitivity of an acoustic emission instrumentation. Requirements have been added for the use of the time of flight diffraction without the supplemental scan of near surface. Article 9, paragraph T953, remote visual, has been revised to accommodate deployment mechanisms like unmanned aircraft vehicles and systems, and adopted 19 updated ASTM specification documents. In Section 6, the definition of relief valve was added to Article 2, so it was consistent with Section 13. And added clauses to paragraph 6.4, pressure relief discharge piping, to align with similar changes made to Section 4, paragraph HG 716.6, along with the creation of Section 13, Section 12.8. In Section 7, a new Section 103.1.4 was added to include operational information for changeover valves. In Section 8, Division 1, a new paragraph, UG 84D3, was added to clarify the impact test requirements for diffusion welding. Paragraph UG 101A5 was added to address sharing of proof testing reports between manufacturers owned by the same entity. Part UHX has been realigned and revised for consistency between the heat exchanger types. The shell and channel coefficients have been revised to be based on the mean diameter instead of the inside diameter, which is consistent with PDB 7. The Part UHX and Appendix 26 design rules, which are identical to Part 4.18 and 4.19, Division 2, have been removed and point to Part 4.18 and 4.19 when appropriate. This will enable identical requirements for all heat exchangers, resulting in easier maintenance through one set of rules. And revised the PRT designator to PRT 8-1 throughout Section 8, Division 1. For Section 8, Division 2, Part 2 has been revised to remove certifying engineers for Class 2 design by rules applications. This action will eliminate conflicts with international engineering registration requirements for the majority of applications. Part 4.18 has been realigned and revised for consistency between the heat exchanger types. Paragraph 4.2.5.7, Category F, Locations, has been added in order to assign a common joint category to tube sheet welds. Paragraph 5.4, Protection against failure from buckling, has been completely rewritten, and a new table of load cases, Table 5.8, has been added. paragraph 5.5.2.4, and table 5.10 have been revised and now provide a quick and simple method to screen components in cyclic service, eliminating the need for a full fatigue analysis, and revise the PRT designator to PRT 8-1 throughout Section 8, Division 2. And in Section 8, Division 3, KD 430, the minimum delta K of the calculation of crack growth rates now includes carbon and low alloy steels with SY less than or equal to 90 KSI. KD 322 provides additional clarity, the logarithmic interpolation between tabular values for individual design curves in figures KD 320.1, KD 320.1M, KD 320.2, and KD 320.2M. This new addition allows for a linear interpolation for an intermediate ultimate tensile strength. KM 270 now includes the notch tensile strength test along with the calculation of the notch strength ratio. KM 234.1b has been revised to lower the minimum design metal temperature for all materials that are not fully austenitic stainless steels. In KG 310, KG 311, and KG 323, along with KD 740, are revised to support manufacturers seeking to use a single user's design specification for the production of vessel designs intended for use across multiple jurisdictions. In Section 9, KG 108 has been revised to remove the 1962 provision and clarify the status of old PQRs when writing a WPS to a later edition. The definition of initial heating interfacial pressure was added to KG 109.2, and previous omissions of sidewall fusing was added to pertinent definitions within KG 109.2. Table QW 264 has a new requirement that includes carbon equivalent limits for applicable steel alloys when laser welding is performed in order to address the increased risk of any cracks occurring. A new paragraph in QW 403 also includes the new variable for a change in base metals. Table QW QB 422 has been revised to include weld metals based on SFA classification, SFA 5.9, SFA 5.18, and SFA 5.28. A non-mandatory Appendix L has been revised to further clarify the qualification requirements for welders and welding operators. Section 10, clarified service life requirements for Class 3 vessels in 8-100.6 to indicate that the service life for glass fiber reinforced vessels is limited to 20 years, but the maximum service life is not limited for carbon fiber reinforced vessels. And in 8-700.5.8, other leak test methods for Class 3 vessels that may be more reasonable and cost-effective, but still yields satisfactory results based on experience to date are now permitted. Section 11, Division 1, IWB 2200B and IWC 2200B have been revised to indicate that construction code examinations may be credited for Section 11 pre-service examination credit, and that these examinations may be performed by personnel that are qualified in accordance with Section 11 or the construction code, which may be different than Section 3. IWL 2330 has been revised to address the use of the term registered professional engineer. In addition, the Responsible engineer requirements are now applicable to plants located outside of the United States and Canada. Mandatory Appendix Supplement 1 has been revised to allow use of calibration blocks fabricated from similar chemical analysis, tensile strength, and metallurgical structure. And Mandatory Appendix 8, Supplements 2, 4, 5, 8, 10, 11, 14, and 15 have been revised. The requirement for specimen identification and identification to be obscured or concealed to maintain a blind test has been removed. The title and contents of Section 11, Division 2 have been revised to replace the term power plant with facility to signify the use of the code for nuclear facilities in addition to power plants. 4-1.3.2D has been revised to clarify how many non-destructive examination level 3s are required for monitoring and non-destructive examination, and what the NDE level 3 requirements are in order to be certified for NDE methods and techniques. RIM 1.2 has been revised and now requires that the same edition of Section 11, Division 1 must be used and referenced in Section 11, Division 2. RIM 2.7.3 has been revised to include any manding methods approved by the Monitoring and Non-Destructive Examination Panel for creating a pre-service baseline. RIM 4.2.4 has been revised to clarify when NDE volumetric and surface examinations may be used, and leakage testing is not applicable after a repair or replacement activity. In Section 12, TG 110.2A has been revised from 3,000 to 2,000 psi to align with the upper limit in Modal Appendix 4. Paragraph TD 320 has been added to address quick actuating devices. It will reference Section 8, Division 1, UG 35.2, non-mandatory appendix FF. TOP 170A has been revised to outline that the pressure relief device shall communicate with the vapor space of the vessel, and the requirement for 450 liters has been removed since it is no longer applicable. Modal Appendix 1, Article 2, Paragraph 1-2.1c has been revised to correct the minimum set pressure to 110% of MAWP or 3.3 psi, whichever is greater. TS 110A, TS 200, Form T-2A, Form T-2B, Form T-2C, and non-mandatory appendix D, Item 1, Item 3, and Note 1 have been revised to change PRT to 12 PRT to match the designator shown in CA1 2020, Table 1.1-1. Non-mandatory appendix E60 has been revised to change the required minimum melting point of brazing material from 525 degrees Celsius to 538 degrees Celsius. And non-mandatory appendix E6P was added. This new section requires pipe joints to be threaded, welded, or flanged. And finally, in Section 13, Paragraph 3.3.2, seat and discs, the meaning of the term steam cutting has been elaborated on. In Paragraph 3.4.2.3, test results, guidance, was provided on what to do when valves cannot be adjusted to meet blowdown performance per table 3.4.2.3-1. In Part 3, Section 3.5, Part 4, Section 4.2, and Section 1-2, definitions for assembler and manufacturer were revised for clarity, and any requirements have been moved to the body of the standard. In Section 3.6 and Table 3.6, set pressure tolerance of -0% to +10% has been added to Table 3.6.1.1-2 for UV valves, and the sole source of overpressure is exposure to fire or heat. And in 3.6.4, seat tightness test, water and gas test media have been generalized to incompressible and compressible fluids.
Thank you so much to the ASME team for walking us through these new changes. We really appreciate your time and your input here today. And thank you to everyone who took the time out of your day to watch our webinar here on the key changes to the 2023 edition. Thank you and have a great day.
Hi again, everyone. Matt with Techstreet. Thank you for taking the time to watch our webinar. I hope that you enjoyed it. If you have any questions, please feel free to reach out to us. Email is enterprise@techstreet.com, or reach out to your sales representative for more information. Thank you again for watching our video and have a great day.